So after we learned about the properties of acids and bases, okay, we did some of these practice problems in class, and some of them were for homework. So trust me, this video will not be posted until your homework has been turned in. But let's go ahead and go over them so if you're reviewing for your test, you can remember. So a compound that tastes sour has base acids in them. But if it tastes bitter, it's a base. If it's going to turn red litmus paper blue, remember, blue for base. If it turns blue litmus paper red, then it is an acid. If it is clear when mixed with phenolphthalein, according to our notes that we took in our last video, that is an acid. And if it turns pink when mixed with phenolphthalein, that is a base. If it reacts with metals, that's an acid. And if it contains hydronium ions, which are H3O+, that is also an acid. If it has a pH less than 7, so from 0 to 7, that is an acid. If it has a pH greater than 7, then it is a base. If it feels slippery, then it is a base. And if it conducts electricity, that could be both acids and bases. Okay, so that's just kind of what we talk about there. And those notes, those answers are purely based on these properties that we went over and you should have in front of you and came from the previous video. But if we want to identify these compounds as either being an Arrhenius acid or an Arrhenius base, a Bronsted-Lowry acid, or a Bronsted-Lowry base, remember, things are allowed to be both Arrhenius acids or Bronsted-Lowry acids or Bronsted-Lowry bases. Okay, but it can't be both an acid and a base at the same time. So that could be a thing. So let's go ahead and take a look here. So H2CO3. Well, it starts with an H, so that means it is an acid, and it is an Arrhenius acid and a Bronsted-Lowry acid. Okay, so that's because there's no difference between Arrhenius and Bronsted-Lowry acids. Now, NH3. NH3 is ammonia, okay? It does not start with hydrogen. Okay, it does not have OH. This is only a Bronsted-Lowry base. If nothing else, that is an example from our notes that I gave you specifically right here that is listed only as a Bronsted-Lowry base. Okay, so NaOH has hydroxide in it, and so that means it is an Arrhenius base specifically because of the OH, but it could also be considered a Bronsted-Lowry base because that OH can accept an additional hydrogen. Calcium hydroxide, again, could be an Arrhenius base or a Bronsted-Lowry base. It can be both. And then H3PO4, because it starts with H, that means we're going to have an acid, and I'm just going to write the word both. It can be both Arrhenius and Bronsted-Lowry. Okay, so the main thing out of here, the only thing that was not both was number 2, ammonia. That's the biggest example, and you want to keep in mind that when you're looking at these, the main thing is knowing, okay, this is an acid, this is a base, that sort of thing, which you can tell the difference because they either start with H or they don't start with H. So let's continue on. So also in our homework, okay, we had this part here where it talked about how we mentioned how acids and bases, labeling the main acid and bases are going to be the reactant, and the conjugate base, conjugate acid, or their partners are always going to be listed on the product side of the equation. And so we want to label each chemical in this equation as either an acid, so A for acid, B for base, Ca for conjugate acid, or Cb for conjugate base. So let's look at question number 1. The first thing that stands out to me is I see OH minus. That has to be a base. It's the definition of an Arrhenius base. So if that is the base, then that means NH4 has to be the acid. Okay, because that's the only thing that can be on the left side of the arrow is one acid and one base in a neutralization reaction. And so the acid is NH4. I see NH3 on the other side. The only difference between these two compounds is one hydrogen, so that means they are partners, and an acid will be partnered with the base. So if NH4 is the acid, its partner, NH3, has to be the conjugate base, which leaves water as the conjugate acid. And that means water is the partner, which I'm going to add another highlighter here. These two have to be partners. They only differ based on the 1H plus. Now, if we look at question number 2, I'm going to look at CO3 too. Now, I notice that when I look on the other side, this one must be its partner. It also has CO3. Now, what I notice, though, is that HCO3 has the hydrogen and CO3 2- does not. So that must mean this is the conjugate acid and this is the base. Another way I know is that OH has to be a base, and so that means it's the conjugate base of water, which in this case is behaving as an acid. If you have water, I highly recommend labeling that one last, because it's a lot easier to figure out which one's behaving as the acid or a base by looking at the other options. And then in number 3, we see this introduction of sodium in here. Guys, you can ignore sodium. Sodium does kind of a double replacement thing, but if you ignore sodium, you see that you have H2PO4 and H3PO4. So what that means is this is our acid and this is the base. Okay? The conjugate acid has an extra hydrogen compared to the base. And we see OH here, which means this has to be the conjugate base, and that means water is behaving as an acid again. Now, I know that in all 3 of these examples, water was behaving as an acid, but it doesn't always have to be. Remember that water is listed as an acid and a base. In these 3 examples, it just happened to be an acid, but it will not always be that way. And so this kind of just reviews some practice problems and things like that that you need to be able to know for your test. Good luck.